Let's start solving question number 1 from height and distance practice set 1. A small boy is standing at some distance from a flag post. When he sees the flag, the angle of elevation formed is 45 degree. If the height of the flag post is 20 feet, what is the distance of the child from the flag post? Let's start solution with the construction of this above scenario. So first, let me draw the flag post of height 20 feet. Okay. Now, there is a boy standing at some distance. We are required to find that particular distance. Okay. So here, this is the distance. Here is the boy standing. And let's join the top of the flag post to the point where the boy is standing. Okay. Now, let's name it as A, B, and C. So here AB is the flag post of height 20 feet. And BC is the distance between the flag post and the boy, where the boy is standing at the point C. And the angle of elevation formed is 45 degree. That means angle ACB is 45 degree. Okay, so we are required to find the distance between the child and the flag post, correct? So let's start with the solution. First, consider triangle ABC. Okay, in triangle ABC, we can write the ratio of AB and BC, that is equals to tan 45 degree, because here we are considering the angle C. So AB by BC equals to tan 45 degree. Now, please put all the values. Here we only know the value of AB, that is 20 by BC, and we also know the value of tan 45 degree, that is 1. Do the cross multiplication, we got the value of BC as 20 feet. So here the distance of the child from the flag post is 20 feet. That means option A is the correct one. Let's start solving question number 2. Two posts are x meters apart and the height of one is double that of the other. If from the midpoint of the line joining their feet an observer finds the angular elevations of their tops to be complementary, then the height of the shorter post is. Okay, so let's start solving with assuming that the height of the shorter post be, say, h meter. Okay, since the the larger post is double of the height of the shorter one, so we can say the height of the another post is 2h meter, correct? Now look here, the angular elevation of their tops to be complementary. Okay, what does it mean that the complementary angles? If the sum of two angles are equals to 90 degree, let's say A, an angle A and another angle is B, and the sum of these two angles is 90 degree. So we can say this A and B, these two are complementary angle, correct? So here we can assume the angular elevation of one of the top of the one post, say theta. So another angular elevation should be 90 degree minus theta. Okay, so we are done with the information part. Now let's start with the construction, that there are two posts of x meters apart. So here, let's draw the larger post first, and here is the another one. Okay. If from the midpoint of the line joining their feet, okay, from the midpoint, let's say here is the midpoint. So this is the construction. Now name it as A, B, C, D. Okay. So we can say that the angular elevation to the top of the shorter post be theta, and the angular elevation of the to the top of the larger post is 90° minus theta. Okay, and the height of DE is h, and the height of AB is 2h. And already we know that the posts are x meter apart distance. That means BC is, and C is, since C is the midpoint, so BC is of x by 2, also CD is of x by 2. Correct. Now let's start with the solution with the steps. That is, first consider the triangle ABC. Consider the triangle ABC. Right? Now from ABC we can write the ratio of AB and BC, means the height and the base, that is of tan 90° minus theta. So here AB by BC equals to tan 90° minus theta. Right? Let's put the values of AB, which is 2h and x by 2. Also, tan 90° minus theta gives us the value of cot theta. So it's equals to cot theta. Let's name it equation number 1. And also from triangle CDE, let's consider this triangle CDE. We can write DE by CD as tan theta. Right? So h by x by 2 equals to tan theta. Name it as equation number 2. Okay, so from this two equation 1 and 2, also we know that tan theta is reciprocal of cot theta. Correct? That means we can write from equation number 2, x by 2 by h equals to cot theta, the reciprocal of tan theta. Correct? So from equation 1 and 2 we can write, from 1 and 2 we can write that 2h by x by 2, 2h by x by 2, which is cot theta, and also x by 2 by h, that is also cot theta. X by 2 by h, both are cot theta. So let's do the cross multiplication. 2h square x by 2 whole square, that means 2h square x square by 4. And here we are required to find the value of h, that means h by x square by 8 square equals to x square by 8. That will give us the value of h, x by 2 root 2 meter. That means the correct option is option A, x by 2 root 2 meter. That is the height for the shorter post. Okay. Question number 3. The horizontal distance between the two towers is 120 meter. The angle of elevation of the top of the first tower when seen from the top of the second tower is 45°. If the height of the second tower is 60 meter, then find the height of the first tower. Okay, so let me draw it first, that the horizontal distance between two towers is 120 meter. Okay, here is the two tower. The angle of elevation from of the top of the first tower when seen from the top of the second tower is 45°. So the first tower is larger in distance. Let's say here in this distance the shorter tower is. So when seen from the top of the shorter tower to the top of the first tower, the angle of elevation is 45°. Okay, now E, B, C, D, E. The distance between these two towers is 120 meters. So the length of CD is 120 meter. The height of ED is 60 meter. From the diagram, we can see that CB equals to DE. That means this also 60 meter, correct? Now, we can assume the height of AB as H meter. Here we are required to find the value for H plus 60 meter, correct? So also from the diagram we can see BE is equals to CD. That means this is also 120 meter, correct? So here we can consider the triangle ABE. ABE. Considering the triangle ABE, we can write H by 120 equals to tan 45 degree. Again, we know the value of tan 45 degree, that is 1. So doing the cross multiplication, we can write H equals to 120 meter. That means total height of another tower is AB plus BC. So it is 120 meter plus 60 meter. 180 meter is the correct answer. Option C is the correct answer. Question number 4 states that ABC is a triangular park. So let's say this ABC is a triangular park with AB equals to AC and both are 100 meters. Okay. Next, a clock tower is situated at the midpoint of BC. So let's say the midpoint is D, and at the point D, a clock tower is situated. The angles of elevation of the top of a tower from A and B point respectively, say okay, this is cot inverse 3.2 and this one is cosec inverse 2.6. So we can denote the angle as alpha. Let's say the angle of elevation from the point A to the top of the tower is alpha, and from the point B to the top of the tower is beta. Okay, so here PD refers the clock tower. Okay, and since it's situated at the midpoint, so obviously it is right angle. It makes a right angle at this point D. Now we can assume the height of the clock tower as H. Let us assume the height of the clock tower as H. Okay, so here we have drawn a perpendicular. We joined AD, so it will make another right angle triangle. Now let me zoom it, the triangle APD. How will it look like? Will it look like this? ADP, where angle is alpha and PD, height H. And also if I zoom the triangle PDB, then it will look like PDB. This angle will be beta and the height is H. So here we are required to find the height of the tower. That means the value for H. Okay, let me figure out it that the alpha, we have assumed the alpha in refer of the value, that is cot inverse 3.2. Okay, that means I can write cot alpha equals to 3.2, and beta in refer of the value cosec inverse 2.6. That means I can write cosec beta as 2.6. Okay, so here in triangle PAD, from PAD I can write that AD by PD equals to cot alpha, correct? So AD will give me the value of H cot alpha. Okay, let me name it equation number 1. Same from triangle BPD, I can write BD by PD equals to cot beta. Okay, and also the value of BD I will get as H cot beta. Okay, now look at the triangle ABD, this triangle. Okay, so here in triangle ABD, what can I write? Since this is a right angle triangle, correct? This is the 90 at D. We get a 90-degree angle. So this is a right angle triangle. That means AB is the hypotenuse here. So according to the Pythagoras theorem, we can write AB square equals to AD square plus BD square. Correct. Now let's put the value of AD and BD from, let's name it equation number 2, from equation 1 and 2. So we will get the value of AB as, after taking common, okay, H cot alpha whole square plus H cot beta whole square. That means after taking common 8 square, I can write it as cot square alpha cot square alpha plus cot square beta. Correct. Now look at here, we are given with cot alpha value. So from it, we can easily write the value of cot square alpha, but we don't know the value of cot beta. How to get that particular value? We are given with cosec beta, right? So what is the relationship between cosec theta, mean cosec beta and cot beta? Okay, so cosec square beta minus 1 will give us the value of cot square beta. This is the relation. So first find out the value for cot square beta. Let's check. Cosec square beta means 2.6, correct? So here 2.6 whole square minus 1 will give us the value for cot square beta. Okay, we will keep it this like this, and we won't do further calculation. We'll do it in the equation itself. So let's write it down. AB square equals to AB square. Okay, I was missed to write that square in this line. So here AB square equals to AB square equals to 8 square. Now cot square alpha means 3.2 whole square. 3.2 whole square plus 2.6 whole square minus 1. Okay. Yes. So let's do the further calculation. Also, we are given the value of AB as 100. So 100 square. 10.24 plus 5.76. Okay, after doing the further calculation, I will get this value as 625. That means the value of H as 25 meter. Root under 625 will give us the value 25 meters. So the answer is the height of the clock tower is 25 meter. Correct. Now check which option it matches with. Yes, option B is the correct answer. Question number 5. The angles of elevation of a balloon from two consecutive kilometer stones in its same side are 60 degree and 30 degree respectively. Then the height of the balloon in Kimi is, there are 4 options given. Now, what does it mean, two consecutive kilometer stones? That means the distance between two stones is 1 kilometer. So let's start with the drawing. Let's say this is the height of the balloon. Okay. Now, That's the distance. So let's say here is the first kilometer stone and the next kilometer stone is this at this point. So we can say that name them A, B, C, D. So here the distance between CD is 1 kilometer. Okay. And let's say the distance between BC is X kilometer. And we are required to find the height of AB. Okay. And here also the angle of elevation, the first is 60 degree and the next one is 30 degree. Next one is 30 degree. So let's start with the solution. First, we can consider triangle ABC. So here A by BC equals to tan 60 degree. We can put the value of BC, that is A by X. That is, also we know the value of tan 60 degree, that is √3. Let's name it equation number 1. Next, consider triangle ABD. So here AB by BD is equal to tan 30 degree. Okay. AB by BD means BC plus CD. So X plus 1. And also we know the value of tan 30 degree is 1 by √3. Name it equation number 2. Now from equation number 1, we can find the value of AB √3x. Also from 2, we can find the value of AB x plus 1 by √3. Correct. Both the equation gives us the value of AB. That means these two are equal. So let's make them equal. √3x equals to x plus 1 by √3. Do the cross multiplication. 3x x plus 1. So that means (2x) equals to 1. 3x minus 1. So the value of x is half kilometer. So option B is the correct answer here. Half kilometer. Question number 6 states that the angle of elevation of a building changes from 45 degree to 60 degree when a man walks 20 meters towards it. What is the height of the building? I have already done with the construction part. Let's say AB is the building. AB is the height of the building and the man was standing at the point D in the first place. Then he comes towards the building 20 meters. So now he is at point C. So the angle of elevation also changes from 45 degree to 60 degree. So let's start with the solution steps. First, consider triangle ABC. We can write AB by BC equals to tan 60 degree. Let us assume that the height of AB is h meter and the distance of BC is x meter. So we can write h by x equals to, also the value of tan 60 degree is √3. So we can write h equals to √3x. Let's name it equation number 1. Next, consider triangle ABT. Okay, so here AB by BD equals to tan 45 degree. We can write h by x plus 20 equals to 1. So it will give us the value h equals to x plus 20. Let's name it equation number 2. Now both the equation gives us the value of h. So they are equal in value. √3x, we can write from 1 and 2, √3x equals to x plus 20. Let's take x common. √3 minus 1 equals to 20. Or we can write x equals to 20 by root 3 minus 1 meter. Okay, so here from the options, from the given options, we can see that option A, not A, okay, it's 20 root 3, no. So none of this, because we have got the answer as 20 by root 3 minus 1, and that's not provided in any of these options. So here we will go for option E, none of this. Question number 7 states that a 6 feet tall man finds the angle of elevation of the top of a 24 feet high pillar and the angle of depression of its base are complementary angles. Then the distance between pillar and man is, okay, 4 options are given. So let me discuss the construction first. As you have seen, I have already done with the construction here. CD represents the man who is 6 feet tall, and AB is the 20 feet high pillar. Okay, since according to the diagram, we can say that CD equals to EB. That's why EB also 6 feet. So the rest of the part, that means AE is of 18 feet. How can we got it? Because 24 minus 6, we will get 18 feet, correct? Next, the angle of elevation, depression of its base are complementary angles. The angle of elevation of the top and the angle of depression of its base are complementary angle. Let's say the elevation of the top is angle alpha. As I have already told you, the relation between two complementary angles are the sum of the angles will be 90 degree. So the other angle can be represented as 90 degree minus theta, which is angle of depression. Since this EDB and CBD, these two are alternate angles, so these two are equal. So we can also write 90 degree minus alpha here, correct? So here we are required to find the distance between the pillar and the man. That means CB. Also, according to the diagram, we can say CB equals to DE, correct? So let's start with the solution. First, consider CDB, this triangle. Okay, so from CDB, angle C is 90 degree. We can write CD by CB tan 90 degree minus alpha, correct? So we can write 6 by CB, that is cot alpha. From the complementary angle, we already know tan 90 degree minus alpha give us the value for cot alpha. Okay, so again from it we can write, since cot alpha is the reciprocal of tan alpha, we can represent it in terms of tan alpha, that is CB by 6. So the value, okay, so let it be, let's name it equation number 1. Okay, next, okay, now next, since CB is equals to D. Now let's consider the triangle ADE. Okay, ADE. So AE by DE, correct? Again, we can write tan alpha. Okay, so AE means 18 and DE, in place of DE, we can write CB because these two are equal. So CB, that is also tan alpha. From 1, we can put the value of CB, that is 18 by 6 tan alpha, right? So another CB is there. That means tan square alpha becomes 3. So tan alpha will give us the value root 3, right? So here Here, let's put the value of root 3 in equation number 1. So we can write from 1 root 3 equals to CB by 6. That means CB equals to 6 root 3. So 6 root 3 feet is the distance between the pillar and the man. Okay. Question number 8 states that a person standing at the end of the shadow of a tree measures that the length of the shadow is 1 by root 3 times the length of the tree. So let's say here AB is the tree, okay, and the person is standing at the point C. So here BC is the shadow, length of the shadow. Okay, so we can assume the length of the tree, say H. That means the length of the shadow will be H 1 by root 3 times of H. So it becomes H by root 3. Okay. Now, at what angle of elevation will the man see the sun? Let us assume the angle of elevation as theta. Okay, so let's start with the steps. Now we can consider triangle ABC here, where B is 90 degree, angle B is 90 degree. So from triangle ABC, we can write AB by BC equals to tan theta. Now let's put the value for AB, H by root 3 tan theta. So we can write H by 1 root 3 by H as tan theta. Both H got cancelled. So tan theta equals to root 3. Now please remember at what value, at what degree we get the value of tan as root 3, that is tan 60 degree. So after cancelling both tan, we can say that theta equals to 60 degrees. So at what angle of elevation will this man see the sun? The angle of elevation at which the man sees the sun is 60 degree. Option A is the correct answer. Question number 9. Two poles of equal height stands on either sides of a roadway which is 80 meter wide. So let's say this DB is referring to the road which is 80 meter wide, and CD and AB are the two poles of equal heights. So we can assume the height as H meter. Okay, both are H meter. At a point on the road way between the pole, let's say that point is E, the elevation of the tops of the poles are 45 degree and 30 degree. Find the height of the poles. Okay, so first let's consider triangle CDE. So from CDE, we can write, since one more thing, since the road is 80 meter wide, so let's say BE is Y meter. So DE should be 80 minus Y meter. Okay. So here CD by DE equals to tan 30 degree. So in place of CD, we can write H by 80 minus Y equals to 1 by root 3. Correct. So from it, we can write H in terms of Y, that is 80 minus Y by root 3. Let's name it equation number 1. And triangle ABE, we can write AB by BE equals to tan 45 degree, which is 1. So ABH by Y equals to 1. So we can, from here, we can write H equals to Y. Let's name it equation number 2. Now from equation 1 and 2, I can write Y equals to, since both of the equations are representing the value of H, so we can write Y equals to 80 minus Y by root 3. That means root 3 plus Y equals to 80. So Y can be written as root 3 plus 180. That means Y equals to 80 by root 3 plus 1. Since h equals to y, so also we got the value of h as 80 by root 3 plus 1 meter. So here 80 by root 3 plus 1 meter, option A is the correct answer. Question number 10 states that a man 2 meter high walks at a uniform speed of 6 meter per minute away from a lamppost, which is 5 meter high. Find the rate at which the length of his shadow increases. Let's say here AB is the lamppost, okay, which is 5 meter high. And here CD is the position of the man at the beginning, okay, and here DG refers the shadow of that person. And after after few seconds, after few moments, the position of the man when he walks at a uniform speed of 6 meter per minute, the position of the man becomes at the becomes EF, okay, and that time his shadow is FH, okay. So here we can say that AB equals to 5 meter, CD equals to 2 meter, and also EF equals to 2 meter. Now from triangle ABG and triangle CDG. Since these two triangles are similar, so we can write that AB by CD, also BG by DG, means the ratio of their sides are equal. So from here we can write that the value for AB, which is 5, so BG by 5 equals to DG by 2. And let's equate this ratio with K, where K is the ratio constant. So we can write BG as 5K and DG as 2K. Okay. Next, we will consider triangle ABH and triangle EFH. This two triangle, okay. Again, they are similar. So we can write AB by EF equals to BH by FH. The ratios will be equal. So from here, we can write that BH by 5 equals to FH by 2K. And again, we will assume a ratio constant. Let's say it P. So we will get the value of BH as 5P and the value of FH as 2P. Okay. Now, what is the value of change in shadow? That is the FH minus DG, because at the first position the shadow of the person was DG, and after he walks several meters, his position got changed, the shadow becomes FH. So here the change in shadow, we can write FH minus DG. So that is 2P minus 2K. So taking common, P minus K. Okay. Next, also we know that DF equals to 60. Why? Because it's given the position as 6 meter per minute. Speed of this person is 6 meter per minute. If he has taken to move to that position t minutes, so obviously the distance will be 6t, right? As speed of the person is 6 meter per minute. So df can be found as bh minus fh subtracted by bg minus dg. Let's check it here. bh minus fh will get how much portion? bf portion, right? So from that you are going to subtract bg minus dg. Okay, so here equals to 60. Okay, so we already know the value of this. 3p minus k equals to 60. So we can write 2p minus k by t equals to 4. Okay, so here 2p minus k means the distance, yes, the change in shadow, and the change in shadow per minute. So change in shadow per minute, that is the record of change, means that is the what say speed. So here required rate of change is 4 meter per minute. Okay, so this is the required rate of change, 4 meter per minute. So here option A is the correct answer. Question number 11 states that on a horizontal plane, there is a vertical tower with a flagpole on the top of the tower. At a point 10 meters away from the foot of the tower, the angle of elevation of the top and bottom of the flagpole are 60 degree and 45 degree respectively. Find the height of the tower and the flagpole mounted on it. Okay, so let's start with the construction first. Let's say this is the tower and there is a flagpole on top of it. So let's say this is the flagpole. Now here is the ground. Okay, so the angle of elevation of the top of the flagpole are 60 degree. That means it is 60 degree, this angle, and the bottom of the flagpole are 45 degree. So here the bottom is 45 degree. The distance, okay, 10 meter away, the point. So it is 10 meter. So we can assume that the height of the tower as y meter and the height of the flagpole as 10 meter. Okay, so let's start with the solution steps. First, consider triangle ABC, this triangle. So from ABC, we can write BC by BA, that is tan 45 degree, means y by 10 equals to 1. So we got the value of y, that is 10. Okay, so here the height of the tower is 10 meter. Now let's consider triangle ABD. Okay, so BD by AB equals to tan 60 degree. Right now BD means y plus x. So we have already got the value of y as 10 meter, we will write 10 plus x by 10 equals to root 3. That means the value of minus 10. So we can write 10 after taking common 10 root 3 minus 1. So here's the value for x, that is 10 multiplied by root 3 minus 1 meter. So we got the height of the tower 10 meter and the height of the flagpole 10 multiplied by root 3 minus 1 meter. Here option A is the correct answer. Question number 12 states that a vertical pole is 75 meter high. Find the angle subtended by the pole a point 75 meter away from its base. Okay, so let's start with the construction first. Let's draw a vertical pole. Next, there is a point 75 meter away from it. At where the angle of elevation we are required to find. Let's join to the top of the vertical pole. Now we can name them as A, B, C. Here BC is the vertical pole which is 75 meter high, and this is the distance from the base of the pole and that point, another 75 meter, and we can assume that the angle of elevation as theta. So from considering the triangle ABC, we can write BC by AB tan theta. Let's put all the values of BC and AB. Both are 75 tan theta. So we can see that tan theta equals to the value 1. Now, do remember at what degree, at what angle we get the tangential value as 1, that is tan 45 degree. So from here we can see theta equals to 45 degree. That means the angle subtended by the pole a point to the pole from a point that is 75 meter away from its base, that is 75 degree. Option B is the correct one. Question number 13 states that two ships leave a port at the same instant. One sails at 30 km per hour in the direction north, 32 degree east, while the other sails at 20 km per hour in the direction south, 58 degree east. After 2 hours, the ships are distant from each other by, there are 4 options given. You need to find the distance between two ships. So I have already done with the construction. Let's say here the two ships started from the point O at the speed of 30 km per hour and 20 km per hour respectively. Okay. After 2 hours, they reach at the point A and B. Fine. So here angle NOA is 32 degree and angle SOB is 58 degree. Now from the according to the diagram, we can find the measurement of angle AOB. That is, since NOS is a straight angle, so its measurement is 180 degree. That's why angle AOB will be 180 degree minus 32 degree plus 58 degree. So it becomes 90 degree. Okay, so it's a right angle triangle, correct? It's a right angle triangle. Now, since AOB is a right angle triangle in which OA is given the distance of one ship at in 2 hours, that is at the rate of 30 km per hour speed. So OA is 2 multiplied by 30, 60 km, and OB is the distance of another ship which is at the speed of 20 km per hour. So 2 multiplied by 20, 40 km. So the length of OA 60 km and OB 40 km. Now, using Pythagoras theorem, from considering triangle AOB using Pythagoras theorem, we can find the value length of AB, that is under root OA square plus OB square. 60 square plus 40 square. The answer will be 220 root 13 km. Okay, so that's the distance between two ships after 2 hours. So here option C is the correct answer, 20 root 13 km. Question number 14 states that a father watches his son flying a kite from a distance of 40 meters. The kite is at a height of 120 meters directly above the sun. How far is the kite from the father? Look, I have already done with the construction. Let's say at the point A, the father is standing, and at the point B, the son is standing and flying the kite, and C is the position of the kite, okay, at a height of 120 meters from the ground or from the sun. So 120 meter is the length of BC, and since father is standing at a distance of 40 meters, so AB is of 40 meter, and here we are asked to find the distance from the further to the kite, that is the length of AC. So let's consider triangle ABC. Here we can see this is a right angle triangle, so it will satisfy the Pythagoras theorem. So from a Pythagoras theorem, according to the Pythagoras theorem, we can write AB whole square plus BC whole square equals to AC whole square, right? Perpendicular square, the sum of the square of perpendicular and the base equals to the square of the hypotenuse. So here 140 whole square plus 120 whole square equals to AC whole square. So the value of AC will be 1600 plus 14400. So it becomes 16000, and it will be 4000. So that means the value will be the value will be 126.49 meter. So here, how far is the kite from the further? The kite is 126.49 meter from the further. Here option A is the correct answer. Question number 15 states that Sneha is standing at some distance from a tower. When she sees the tower, the angle of elevation formed 60 degree. Find the distance of Sneha from the tower if the height of the tower is 50 meter. So let's say here is the tower, which is 50 meter height, and Sneha is standing at some distance. So the angle of elevation from Sneha to the top of the tower is 60 degree. Let's name it as EBC. So here we are asked to find the distance of Sneha from the tower, that is the length of AB. Now let's consider triangle ABC. Here B is the right angle. Next, we can write BC by AB as tan 60 degree. BC 50 by AB equals to, we know the value of tan 60 degree, that is root 3. So from here, after doing the cross multiplication, we can write the value of AB as 50 by root 3. Since root 3 is an irrational number and it's in the denominator, right? So we have to do the rationalization. So we will multiply another root 3 in the with the denominator and the numerator both. So root 3 multiplied by root 3 becomes 3. So here the answer is 50 root 3 by 3 meter. That's the distance of, that's the length of AB, means that's the distance of Sneha from the tower. So here option A is the correct answer. It is given in question number 16, the angle of elevation of a lamppost changes from 30 degree to 60 degree. When a man walks 30 meters towards it, what is the height of the lamppost? Five options are given. So let's start with the construction first. Let's say here AB is the lamppost of height h meter, and there is a man standing a few meter ahead of the lamppost at this point. Okay, so from this point, from the man, the angle of elevation to the top of the lamppost is 30 degree. Now, what happened? The man started walking 30 meter, started walking towards the lamppost, and he walks 30 meter towards it. Let's say in this position, So from here, the angle of elevation from the man to the lamppost is 60 degree. So it's 60 degree and here is 30 degree. We can assume the height of the lamppost as h meter. Okay, so first consider the triangle ABD, this triangle, the larger one. So from here we can write AB by BD as tan 30 degree. So okay, this is 30 meter and we don't know the value of BC, so we can assume it as X. H by X plus 30 equals to 1 by root 3. From here we can write H root 3 equals to X plus 30, or we can write H by X plus 30 by root 3. Let's name it equation number 1. Next, we can consider the smaller triangle, that is ABC. So considering triangle ABC, we can write AB by BC equals to tan 60 degree. Okay, so here H by X equals to tan 60 degree. The value is root 3. So from it, we can write H equals to X root 3. Let's name it equation number 2. Now, both the equation gives us the same value, that is of H. So we can equate them. It will become X plus 30 by root 3 equals to X root 3. So X plus 30, 3X. Next, we can write 2x equals to 30 and x equals to 15. But here we are asked to find the value of h. That means h equals to 15 root 3 meter. So the height of the lamppost is 15 root 3 meter. Option A is the correct answer. Question number 17 states that Sujata, at a distance of 30 meters from the window, saw a butterfly. The butterfly is at a height of 80 meters above the window. How far is the butterfly from Sujata? Let's say Sujata is standing at the position of the point A, and here at the position B is the window, and at the height of 80 meters above from the window at the position C, there is a butterfly. Okay, so this will be the construction of the above scenario. The length of AB is 30 meter and the length of BC is 80 meter. We are asked to find the distance between Sujata and the butterfly. So we are required to find the length of AC. Let's consider triangle ABC. So according to Pythagoras theorem, we can write the sum of the perpendicular square and the base square is equal to the square of the hypotenuse. So here 80 whole square plus 30 whole square equals to AC whole square. That means AC equals to 640. So we'll get the value as 85.4 meter. The value of AC is 85.4 meter. That means the butterfly is 85.4 meter away far from Sujata. So here option A is the correct answer. Question number 18 states that from the top and bottom of a building, the angles of elevation of the top of a tower that is 30 meter are 30° and 45° respectively. Find the height of the building. I have already done with the construction. Here, AB refers the building. So we can assume that the height of the building as H meter. Next, CE refers the tower. So here the length of CE is 30 meter. But according to the picture, we can say that AB equals to CD. That means CD, this part is of H meter length. So since the total length is 30 meter, we can say DE is 30 minus H meter. Okay. Next, the angle of elevation of the top of the tower from top of the building is 30° and from bottom of the building is 45°. Here we are required to find the height of the building. Also from the diagram we can see BC equals to AD. Okay, so let's start solving this sum step by step. First we will consider the triangle BCE. So from BCE we can write CE by CB equals to tan 45°. CE means 30 by CB and tan 45° will give us the value 1. So we can say that CB is equals to 30 meter. That means AD is also 30 meter. Okay. Now we will consider the triangle ADE. ADE. So from ADE we can write DE by DA, which is tan 30°. Now DE means 30 minus H by AD means we have just got the value of AD, that is again 30. So we can write, also we know the value of tan 30°, that is 1 by root 3. So from this equation we are going to find the value of H 30 root 3 minus H root 3 30. So here H can be written as 30 to take in common root 3 minus 1 by root 3 equals to H. So the value of H is H equals to, if we can rationalize this value, since we have seen that there is a irrational number in the denominator. So after rationalization, in order to rationalize this, we will multiply root 3 with the numerator and denominator both. So we will get 10 root 3 multiplied by root 3 minus 1 meter. So here the height of the building is 10 root 3 by root 3 minus 1 meter. So none of this, since this answer matches with none of the options, so we will go for option E, that is none of this. Question number 19 states that a man is observing from the top of a tower a boat speeding away from the tower. Let's say here A, B is the tower here. It refers the tower. Okay, AB is the height of the tower. The boat makes an angle of depression of 45 degree with the man's eye when at a distance of 60 meter from the tower. So first the boat position is at the point C. The distance from B to C is 60 meter, and as it described, the angle of depression is 45 degree. Then after 5 seconds, the angle of depression becomes 30 degree. Now the position of the boat changed. Now it's in the at the point D. So at this position, the angle of depression of the boat becomes 30 degree. So this is the construction, the diagram of the above scenario. Now we are required to find the speed of the boat. Okay, and we can write the distance as 60 meter, and we can assume the length of CD as x meter. Also, we don't know the height of the tower, that we can assume as h meter. Now let's start with the steps, solution by step. So here, first we will consider the triangle ABC. Okay, so now from ABC we can write AB by BC equals to tan 45 degree. That implies that h by 60 equals to 1. Tan 45 degree gives us the value 1. So from this line, we can imply that h equals to 60 meter. That means the height of the tower is 60 meter. Okay. Next, after considering the triangle ABD, we can write AB by BD equals to tan 30 degree. Next, AB, we already know the value of AB, that is the height of the tower, which is 60 meters. So I can replace AB by 60. And BD can be broken down as BC plus CD equals to, we know the value of tan 30 degree, which is 1 by root 3. Let's put all the values and do the cross multiplication. BC 60 plus x. So from here, we can write x equals to, after taking 60 common, okay, let me tell you the value of root 3 is 1.73 approx. Okay, so here 1.73, we will use this value minus 1, right? Next, from here we can get the value of x as 43.8 meter, right? So we got the length of CD, and this much distance covered covered in 5 seconds, and we are required to find the speed. Now speed of the boat equals to, so 43.8 meter covered in 5 seconds. So per second, the speed is 43.8 by 5 meter per second. Now, let me tell you how to convert speed, which is in the unit meter per second, to kimi per hour. We have to multiply that quantity with 18 by 5. Okay, it will be converted in the unit kimi per hour. That's the rule. So we will use it here, 43.8 by 5 multiplied by 18 by 5. Now it will give us the value in kimi per hour. So here the answer is 31 point, approximately 31.5 kimi per hour. Okay, this is approximate value. So here we can mark option B, that will give us the correct answer, 31.5 kimi per hour. In question number 20, it is given that from a point P on a level ground, the angle of elevation of the top of a tower is 30 degree. If the tower is 100 meter high, find the distance of point P from the foot of the tower. So first let's start with the diagram. Let's say here is the tower, and on the ground, at this position, the point P is located. Now let's join the top of the tower with the point P. So AB is the tower, is the point P, and the angle of elevation is 30 degree. If the tower is 100 meter high, so the height, the length of AB is 100 meter, and here we are required to find the distance, the length of BP, that is the distance of the point P from the foot of the tower. So let's consider triangle ABP. AB by BP tan 30 degree, or 100 by BP equals to 1 by root 3. So from cross multiplication, we can write BP equals to 100 root 3 meter. And we all know that we can assume the value of root 3 as 1.73 approximate. I will put here 100 multiplied by 1.73 meter. We will get 173 meter approximate. So here option B is the correct answer. 21 states that a man on the top of a vertical tower observes a car moving at a uniform speed coming directly towards it. If it takes 12 meters for the angle of depression to change from 30 degree to 45 degree, how soon after this will the car reach the tower? Let's say here AB refers the tower and the man is on the top of the tower. He is looking at a car which is moving towards this tower. At the beginning, the car was at point C. Okay. And that time the angle of depression was 30 degree. Next, after 12 minutes, the position of the car changed and now it becomes D at the point D. And the car took 12 minutes to come to the point D from the point C. Now the angle of depression is 45 degree. So here we are required to find that how long it will take, the car will take to reach the tower. Okay, let us assume the height of the tower as H meter, and the the length of BD, or the length of CD as X meter. Okay, now let's start with the sum. So here first we can assume the triangle ABD. From ABD we can write AB by BD equals to tan 45 degree. That means H equals to tan 45 degree will give us the value 1. So H equals to BD. We can name it as equation number 1. Next, after considering triangle ABC, we can say AB by BC equals to tan 30 degree, where tan 30 degree give us the value 1 by root 3. Now BC can be expressed as BD plus CD, or X equals to 1 by H. Now look here, we have already found from equation number 1 that BD is also H meter. So we can replace here BD with H. H by H plus X equals to 1 by root 3 H, H plus X. So X can be written as, after taking H common, root 3 minus 1. Again, we are going to put the value of root 3. We can approximately, we can take the value of root 3 as 1.73. So 1.73 minus 1 will give us the value 0.73 H. Look, this X meter covered by the car in 12 minutes, right? So we can say that root 0.73 H covered in covered in 12 minutes. So, and the car needs to come h meter because BD equals to h meter. So h meter covered will cover in 12 by 0.73 minutes. From here, approximately we will get the value, we'll get the time as 16 minute 23 second. So yes, this is our answer at option D. 16 minute 23 second the car will take to reach the tower. Question number 22 states that an aeroplane when flying at a height of 3125 meter from the ground passes vertically below another plane at an instant when the angles of elevation of the two planes from the same point on the ground are 30° and 60° respectively. The distance between the two planes at that instant is, four options are given. So here, let's say C is the position of the plane which is flying at a height of 3,125 meter. Okay, and there is another plane top of it at some distance, vertically at some distance at the position D. So we can say that the distance between these two planes, we can assume that distance as x meter. Okay, now the angles of elevation of the two planes from the same point on the ground are 30° and 60° respectively. So here angle CAB is 30° and angle DAB is 60°. We can again assume the length of AB as y meter. So let's start with the solution step by step. First, we will consider the triangle ABC. So BC by AB equals to tan 30°. That means 3125 by y equals to 1 by root 3. So we can say the value of y as 3125 root 3. Let's name it equation number 1. Now, in next, we will consider the triangle ABD. Okay, so here BD by BA equals to tan 60°. Tan 60°. Now BD can be written as BC plus CD. So we can introduce it as 3125 3,125 plus x by y means 3125 root 3 equals to, we know the value of tan 60°, that is root 3. So let's find the value of x from this equation. Okay, let me write it from equation number 1. We have written the value of y. So 3125 plus x equals to, it will give us the value 3125 multiplied by 3. So from here we can find that x equals to 3125 multiplied by 2. So the value of x is 6,250 meter. So here option D, the last option, is the correct answer. Question number 23 states that a vertical tower stands on a horizontal plane and is surmounted by a flagstaff of height 8 meter. At a point on the plane, the angle of elevation of the bottom of the flagstaff is 30° and that of the top of the flagstaff is 45°. Find the height of the tower. Look, in this construction, we can say that AB refers the tower. Okay, and we can assume that the height of the tower as h meter. So, and here AD is the flagstaff, which is 8 meter of height. That means the total height of BD, we can write it as h plus 8 meter. Next, there is a point on the ground at some distance from the foot of the tower, and from that point we can see the angle of elevation of the bottom of the flagstaff is 30 degree, and the top of the flagstaff, that is 45 degree. And here we are required to find the height of the tower. So let's start with the solution step by step. First, we will consider the triangle ABC. Here we can write AB by BC. That will equals to the value with tan 30 degree. So now after putting all those value, we can write H by BC equals to 1 by root 3. So after doing the cross multiplication, we can write BC equals to H root 3. Let's name it equation number 1. Next, we can consider the triangle CBD. So here BD by BC equals to tan 45 degree. BD, we can write BD as H plus 8 meter by BC H root 3. We just have got it from equation number 1 equals to 1. Tan 45 degree will give us the value 1. And in a bracket, we can write from 1. So here H plus 8 equals to H root 3. Now let's write root 3 minus 1, and H can be expressed as 8 by root 3 minus 1 meter. So that's the value for the height of the tower, which is 8 by root 3 minus 1 meter. So here option A is the correct answer. Question number 24 states that there are two buildings, one on each bank of a river opposite to each other. From the top of one building, which is 60-meter high, the angles of depression of the top and the foot to the other building are 30 degree and 60 degree respectively. What is the height of the other building? Look here. Okay, this is the original questions from one of the previous year's paper. So here BC is a building which is 60-meter high, 60-meter high, and AD is another building. And we are here required to find the height of the building AD. Let's us assume that the height is H meter. So we can say that according to the diagram, we can write AD equals to BE. So this is also H meter. So CE can be written as 60 minus H meter. Now the angle of depression from the top of the second building, of the larger building, to the foot of the another building is 60 degree, and to the top of the another building is 30 degree. So it's 30 and this one is 60 degree. So let's start with the solution. First, we will consider the triangle ABC. So here BC by AB equals to tan 60 degree. Now the BC is about 60 meter. So 60 by AB equals to 1 by root 3. Tan 60 degree give us the value 1 by root 3. Okay, sorry, the tan, this part must be trimmed. Tan 60 degree is not 1 by root 3. So in the next line, we will put all the values of BC by AB, BC and AB, that is 60 by AB equals to tan 60 degree will give us the value root 3. That means AB equals to 60 by root 3. We can name it as equation number 1. Next, from the diagram, we can say AB equals to DE. According to the diagram, these two are equal. from now we will consider the triangle CDE. Now we say CE by DE, that is equals to tan 30 degree. So here CE means 60 minus H by DE, which is equals to AB. That means 60 by root 3. So it's 60 by root 3 here. Tan 30 degree will give us the value 1 by root 3. So let's proceed with the calculation. 60 minus H, 60 by root 3, 1 by root 3. It becomes 60 by 3. So 20, H equals to 60 minus 20, 40 meter. So here correct answer is 40 meter. The height of the building is 40 meter. Question number 25 states that the angle of elevation of the top of a tower standing on a horizontal plane from a point A is alpha. After walking a distance a meter towards the foot of the tower of the angle of that angle of elevation is found to be beta. The height of the tower is 4 options are given. Look, we can let's say OP be the height of the tower, which is H meter. We can assume that height. Now there is a point on the ground, let's say the point A, and that angle of elevation from this point to the top of the tower is found to be alpha. After walking a distance a meter towards the foot of the tower, there is a point, let's say B, and from this point the angle of elevation to the top of the tower is beta. Here we are required to find the height of the tower. Again, we can assume the length of OB as x meter. So let's start the solution step by step. First, we will consider the triangle BOP. So here OP by OP equals to tan beta. Okay, let's put the value of OP and OB respectively. H by x equals to tan beta. From here, we can find the value of x as h by tan beta. That means h equals to cot beta. Since cot beta, cot theta is the reciprocal of tan theta, so we can write x equals to h cot beta. Let's name it equation number 1. In the next step, we will consider the triangle AOP. Here, OP by OA equals to tan alpha. Let's put all those values. H by OA can be broken as AB plus BO. So we can write it as A plus X equals to tan alpha. Further, we can write A plus X as H by tan alpha. That means H cot alpha. So from here, we can write x equals to h cot alpha minus a. Let's name it equation B. Now look here, both the equation 1 and 2 refers the value of x. That means these two values are equal. So we can equate these two values. So here h cot beta here h cot beta equals to cot beta equals to h cot alpha minus a. H cot alpha minus a. Cot beta can be written into with the help of cos and sine. So cos beta by sine beta minus cos alpha by sine alpha equals to minus a, or sine alpha sine beta cos beta sine alpha minus cos alpha sine beta equals to minus a. We can we can multiply both the sign with minus. So the left side will become sine beta cos alpha minus cos beta sine alpha by sine alpha sine beta, and minus a will become a plus a. Okay, so here this is the formula for sine alpha minus beta minus alpha. This is the formula for sine beta minus alpha. After doing the cross multiplication, we can write a sine alpha sine beta, and since it's the expansion form of sine beta minus alpha, we will write it as sine beta minus alpha. So that's the height for the tower. So here it matches with option A sine alpha sine beta by sine beta minus alpha is the height of the tower. Our given question is the angle of depression of vertex of a regular hexagon lying in a horizontal plane from the top of tower of height 75 meter located at the center of the regular hexagon is 60 degree. What is the length of each side of the hexagon? 5 options are given. So here I have already drawn a hexagon. Let's say here C, D, E, Q, F, B. So this is a regular hexagon, and at the center can be defined as with O. So there is a tower at the center. Okay, so let's say OA is the tower of 75-meter height. Now there is a point. Okay, since this is a hexagon is a polygon of having 6 sides, right? Now the tower is located at referred as OA. So the angle of depression from the top of the tower, that means from the point A to any vertex, is given that 60 degree. So from the diagram we can say, let's say here AT. So AT is parallel to OB. That means TAB is 60 degree. So from alternate interior angle, we can say that angle OBA 60 degree as well. So it will be 60 degree. Okay. So here we already given with the value of OA, that is 75 meter. The angle OBA, which is 60 degree. So from that, considering the triangle OAB, we can find the length of OB. Okay, so let's do that. Here OA by OB equals to tan 60 degree. That means 75 by OB equals to √3. So from here we can write the value of OB, which is 75 by √3. Let's name it equation number 1. Now we want to find the length of BF. That's the side of this hexagon, right? Also, we can say that OB, let me join all the vertex with the center first. Here. Okay, so also again we can say that OB equals to OF because it's a hexagon. Okay, that means it implies that the opposite angles of opposite sides will be equal. So OBF equals to OFB. So the triangle OBF becomes an isosceles triangle. Okay, isosceles triangle. Now, since we have already given that this hexagon is a regular hexagon, so one more property you have to remember, that the property is that for regular hexagon, all the sides are equal. All the sides for that hexagon is equal, and total angle at the center is 360 degree. So one segment means the angle FBOF, one segmenting, since there are 6 segments, 360° divided by 6. So it becomes 60°. Now this implies that OBF is an equilateral triangle. Lateral triangle. Okay, because already we have proved that the two base angles are equal. So, and the third angle is 60°. So apparently it will appear that all the 3 angles are 60°. That means this triangle is an equilateral triangle. So we can say that OB equals to OF equals to BF. So we have already got the value for OB. That means we can write BF equals to 75 by root 3. Now, since there is an irrational value in the denominator, we can rationalize it by multiplying root 3 with both numerator and denominator. It becomes 3. So 25 root 3 meter. So the side length is 25 root 3 meter. Let's check all the options. Yes, option C is the correct one. 25 root 3 meter is the side of each side, length of each side of the hexagon. Question number 27 states that a building is 50 meter high. The angles of elevation of the top of a building from 2 points on the level ground on its opposite sides are 30° and 45°. Find the distance between 2 points in nearest meters. So here the BD refers the building which is 50 meter high, and there are 2 points on its opposite sides on the ground. One is A, another one is the point C. So we can assume the distance between the building and the point A as x meter. Same, we can assume the distance between the point C and the building as y meter. And the angle of elevation is already given, which is 30° and 45° respectively. Here we are required to find the distance between 2 points, that is x plus y meter. First, let me consider triangle ABD. So here BD by AB, that is tan 30°. So it will give me 50 by x equals to 1 by root 3. So we can get the value of x as 50 root 3. Let's name it equation number 1. Next, consider triangle BCD. So here BD by BC equals to tan 45°. That means 50 by y equals to 1. Tan 45° give us the value 1. From here we can get the value of y as 50. Let's name it equation number 2. Since we are asked to find the distance between these 2 points, that means the distance is x plus y, 50 root 3 plus 50 meter. So it will give us, after taking 50 common, root 3 plus 1 meter. This is the answer. So it matches with option A. Here 50 multiplied by 1 plus root 3 meter is the distance between 2 points. It is given in question number 28. ABCD is a square plot. Okay, let me first draw a square plot here. Next, the angle of elevation of the top of a pole standing at D. Let's say this is the point D. There is a pole standing. Okay, standing at D from A and C is 30°. Let's say this is the point C and ABCD. So this is the point A. Okay, is 30°, and that from B is theta. So this point will be B. Is theta, we need to draw the reference point. Yes, theta. Then tan theta is equals to, so here we're required to find the value for tan theta. A, B, C, D. Here this angle is theta, this angle is 30 degree, and another this angle is also 30 degree. Correct. Now we can assume that let A be the length of the side of the square plot ABCD. Let A be the length of a side of square plot ABCD. Okay. And H be the height of the pole. Okay, standing at the point D. And since the elevations of point P, say P, from the point A and from the point A or C is 30 degree, and that from B is theta, then we can say, considering the triangle PCD, in triangle PCD, okay, we can write that tan 30 degree means what? Tan 30 degree means H by A means PD by CD. Okay. So from here we can write that H by A equals to 1 by root 3. Let's name it equation number 1. Fine. Next in PBD. Okay. After considering the triangle PBD. From PBD, we can write that tan theta equals to H by, okay, now here you need to know the formula for finding diagonal of a square. Okay, if you are given with the measurement of the side, that is A, so that you know that A root 2 unit will be the measurement of the diagonal of that square. So since here PD by BD, BD is the diagonal of the square plot, so the measurement of BD will be A root 2. Okay, if side is A unit, diagonal will be A root 2 unit. Fine. So A by root 2, and this tan theta value we don't know. Okay, so here we need to find that theta value. Correct. So how can we do that? Look here, from BD, okay, so let's say here H by A and 1 by root 2. We also can write it this way. So we already know the value of H by A, this expression from 1, that is root 3. Correct? So 1 by root 3, from 1, we can write 1 by root 6. So tan theta, the what is the value of tan theta? Tan theta is equal to 1 by root 6. So here option B is the correct answer. Question number 29 states that from the foot of a tower on level ground, the angle of elevation of the top of the tower is 30 degree at a distance of 90 root 3 meter. Find the height of the tower. Let's say here AB refers the tower, and we are required to find the height, find the length of AB. Let us assume that length as H meter. Okay, and there is a point on the ground at a distance of 9 root 3 meter. Let's say that point is C, and the length of BC is 9 root 3 meter. From that point, the angle of elevation to the top of the tower is 30 degree. So that's the diagram. That's the construction for this above scenario. Let us consider the triangle ABC. Okay, so here we can write AB by BC equals to tan 30 degree. Let's put all those values. H by 90 root 3 equals to 1 by root 3. Both root 3 got cancelled, and here H equals to 90 meter. So the height of the tower is 90 meter. Option A is the correct answer. Question number 30 states that the height of a tower is h and the angle of elevation of the top of the tower is alpha. On moving a distance h by 2 meter towards the tower, the angle of elevation becomes beta. What is the value of cot alpha minus cot beta? Look here, AB refers the tower. We can, okay, already it's given the height, that is h meter. Now, there is a point on the ground, let's say C, and from this point, the angle of elevation to the top of the tower is alpha. Next, after moving towards h by 2 meter distance towards the tower, there is a point, say D, and from that point, the angle of elevation to the top of the tower is beta. That is the above scenario. And here we are required to find the value for cot alpha, cot beta. Okay, here we can assume the length of BD as X. Okay, next, after considering the triangle ABD, we can write that X by H equals to cot beta. We know the ratio of base and perpendicular gives us the value for cot theta. So here X by H equals to cot beta. Let's name it equation number 1. Next, we can consider triangle ABC. Okay, so from it, we can write that BC by BA will give us the value cot alpha. Let's put all those values. H by 2 plus X by H equals to cot alpha. Let's name it equation number 2. So we have got separately the value for cot alpha and cot beta. Now we are going to find the value for the required expression from 1 and 2. Cot alpha minus cot beta equals to X by H minus H by 2 plus X by H. So let's say after taking the LCM, X minus H by 2 H by 2. Okay, first we need to put the value for cot alpha, right? So H by 2 plus X by H minus X by H. After taking the LCM, becomes H by 2 plus X minus X. So it will give us the value half. So here option A is the correct answer. The required value for cot alpha minus cot beta is half. It is given in question number 31. A man standing at a point P is watching the top of a tower, which makes an angle of elevation of 30 degree. The man walks some distance towards the tower, and then his angle of elevation of the top of the tower is 60 degree. If the height of the tower is 30 meter, then the distance he moves is, 4 options are given. Let me explain the above scenario here. Let's say there is a point on the ground P. Okay, and the man at the beginning, the man was standing at the point P, and he is watching to the top of a tower, let's say A B. Okay, and that is of 30 meter. Now that angle of elevation is 30 degree. After that, he started moving towards the tower, and after a few meters moving towards the tower, that then the man is at the position at the point C, and that time the angle of elevation to the top of the tower becomes 60 degree. So here we are required to find the distance he moves. That means the length of CP. We can assume it as Y. Also, let me assume the length of BC as X meter. So start with the solution step by step. First, we can consider the triangle ABC. Okay, so here AB by BC equals to tan 60 degree. 30 by X equals to root 3. So we can find the value of X as 30 by root 3. After doing the rationalization, we can write it gives us the value 10 root 3. Let's name it equation number 1. Next, we can consider the triangle ABP. So here AB by BP equals to tan 30 degree. So 30 by BP, we already got the value for X, that is 10 root 3 plus Y equals to 1 by root 3. In a bracket, we can write from 1. Let's do the cross multiplication. Okay, so 30 root 3 minus 10 root 3 will give us the value 20 root 3 meter. So the distance he moves is 20 root 3 meter. Option D is the correct answer here. It is given in question number 32, the angle of elevation of the top of an unfinished pillar at a point 150 meter from its base is 30 degree. If the angle of elevation at the same point is to be 45 degree, then the pillar has to be raised to a height of how many meters? 5 options are given. Let's say here the BC is the pillar, unfinished pillar. Okay, and here there is a point on the ground, that is point A, and from this point the angle of elevation to the top of the unfinished pillar is 30 degree, and the distance, the length of AB is 150 meter. Now let's say the pillar has to be raised to the to a height of h meter, and up to at the point D. That means now the angle of elevation from the point A is 45 degree. Okay, and the original height of the unfinished pillar, we can assume it as x meter. So here we are required to find that how many meters of the height has to be raised. So we need to here find out the value of h. So in order to solve this question, first I will consider the triangle ABC. Okay, this triangle. Then BC by AB equals to tan 30 degree. So it will give us the value x by 150, 1 by root 3. From here, I can find the value of is as 150 by root 3. After do the rationalization, I can say 50 root 3. Let's name it equation number 1. Next, we can consider the triangle ABD. Okay, so from here, we can write BD by AB as tan 45 degree. BD means x plus h. So already you have got the value of x, that is 50 root 3 plus h by 150 equals to 1. Tan 45 degree give us the value 1. So 50 root 3 plus h equals to 150 is the answer. So here we can say that h equals to 150 minus 50 root 3. We can take 50 root 3 as common. It will give us the value root 3 minus 1. So after the calculation, we will get the value of this expression as 63.4 meter. That is the answer. That is the value for h. 63.4 meter height to the pillar has to be raised to a height of 63.4 meter. Here option D is the correct answer. Question number 33 states that the angles of elevation of the top of a vertical tower from 2 points distant A and B, where A greater than B, from the base and in the same straight line with it are complementary. Then the height of the tower is 4 options are given. First, let me explain you what about complementary angles. Which angles are called complementary angles? If the sum of two angles are 90 degree, then we can say that each of them are complementary to each other. So here alpha and beta are complementary angles. Let's say here CD is the vertical tower. Okay, and we can assume the height of this tower as h meter. Next, there are 2 points on the ground in the same straight line with the tower. So here the first point is A and the second point is B. The distance between the foot of the vertical tower and the point B is B meter, and the distance between the point A and the foot of the vertical tower is A meter. Okay, so he and also the angle of elevations are complementary. If I find it as theta, so another angle will be 90 degree minus theta. So this is the diagram of the above scenario. Now we can find, from considering the triangle ACD, CD by AD equals to tan 90 degree minus theta. So it will give us the value h by AD means A meter and BD means B meter. So h by A equals to tan 90 degree minus theta. Now tan 90 degree minus theta give us the value of cot theta. So we can write h equals to A cot theta. Let's name it equation number 1. Next, we will consider the smaller triangle, that is BCD. So triangle BCD, from triangle BCD we can write CD by BD equals to tan theta. So here h by B equals to tan theta. Again, I can find the value of h as B tan theta. Let's name it equation number 2. Now both the equations give us the value for h, right? Let's multiply both the equation. So here h squared equals to A cot theta multiplied by B tan theta. We know that tan theta and cot theta, they are reciprocal to each other, so the product of them will give us the value 1. So h squared equals to AB. That means h equals to root under AB. So here root under AB unit. So here option A is the correct answer. The height of the tower is root AB. It is given in question number 34. From the top of a hill 200-meter high, the angles of depression of the top and the bottom of the tower are observed to be 30 degree and 60 degree. The height of the tower is in meter. We need to find the value in meter unit, and there are 4 options given. Let me first explain the above scenario in the diagram. Let's say here AC is the is referred to the hill which is 200-meter high, and here BD is the tower. We can assume the height of the tower as h meter. Okay, so from the diagram we can say that BD equals to CE. So CE also h meter. That means since the total height is 200 meter, so this much portion, the length of AE will be 200 minus h. Also from the diagram we can say BC equals to D. Fine. Next, the angle of depression of the top of the from the from the top of the hill is 30°. So this is angle of depression 30°, and the angle of depression to the bottom of the tower is 60°, right? 60°. So let's start the solution step by step here. First, we will consider the triangle ABC. ABC. So from ABC, we can write AC by BC equals to tan 60°. AC means 200 by BC equals to √3. So we got the value of BC as 200 by √3. Let's name it equation number 1. Next, we will consider the triangle ADE. From ADE, we can write AE by DE equals to tan 30°. Okay, so here E is 200 minus h, and from 1 we got the value of BC, which is equals to DE as 200 √3. So 200 by √3 equals to 1 by √3, right? Let's continue with the calculation. 200 minus h, 1 by √3, 200 by √3. Both the √3 multiplied by √3 give us 3. So it becomes 200 minus h equals to 200. So 600 minus 200 equals to 3h, or 3h equals to 400. That means h equals to 400 by 3. If we convert it into mixed fraction, we will get the value as 133 by 3 meter. So here 133 whole 1/3 meter is the correct answer. That's the height of the tower. Question number 35 states that a person standing on the bank of river finds that the angle of elevation of the top of a tower on opposite side of the bank is 45°. Which of the following statement is correct? There are 4 options given regarding the above scenario. Okay, first let me explain you the diagram. Here, let's say AB is the tower situated on the either side of the bank, and a person is standing on the opposite opposite bank of the river. So let's say at this position at the point C. So the angle of elevation is 45°. 45°. Now we are required to, okay, we don't know the height of the tower and the breadth of the river as well. So we can assume that let AB equals to h meter, the height of the tower. Okay, and BC equals to x meter, the breadth of the river. Okay, also it is given that angle ACB is 45°, right? Now, since ABC is a right angle triangle, so from ABC, we can write AB by BC equals to tan 45°. So from here, after putting all those values, we can write H by X equals to tan 45° will give us the value 1. So H equals to X. That means breadth of the river equals to height of the tower. Correct? So here option B, the second scenario is the statement is the correct. Breadth of the river and the height of the tower are equal. It is given in question number 36. The height of the center of the round balloon of radius r, which subtend an angle alpha at the eye of an observer, while the angle of elevation of its center from the eye is beta, is given by, there are four options given. Let me explain the above scenario first. Let's say here, this is the circle with center C, and let us represent, okay, let us represent the circle means the balloon, the round balloon, the balloon by a circle with center C. Okay, and the radius is r as it's given with radius r. Next, let there is OX is the horizontal ground, means OX is the ground. Okay, let OX be the ground, and let O be the position of the point of observation. This O be the position or the point of observation. Point of observation. Now from O, I have already drawn two tangents. One is OA and OB. We already know that from an external point, we can draw maximum two tangents to a circle. So here OA and OB both are tangents. That means OA and OB, they are equal in length, okay, to the circle. So OA and OB tangents to the circle. To the circle. Already I have joined CA and CB, and then I have drawn a perpendicular from C to the ground, that is CD. Since this is a perpendicular, that means CDO is 90 degree. Okay, so here CD perpendicular to OX. So from that, from this diagram, also it's given that the angle subtended an angle alpha at the eye of an observer. So that means angle AOB, angle AOB is alpha. Since OC is the angle bisector, so we can say that AOC is alpha by 2, also COD is alpha by 2. And also it's given the angle of elevation of its center from the eye. So angle of elevation means BOD, that is beta. So angle B, okay, no, BOD to the center, that means DOC, not B, up to the center, the angle of elevation since it is said that the angle of elevation of its center from the eye. So O is the position of the point of observation, I mean the eye, and from the eye, the angle of elevation of its center. So C is the center. That means DOC, the angle DOC is beta. Okay. Also, OC is the bisector. I have already told you that AOC and COB both are alpha by 2. Now, here from triangle OAC, okay, triangle OAC, let's consider this triangle OAC. From here we can write OC, since this is 90 degree, because we already know the radius is perpendicular on the tangent. So AOC is a right angle triangle. After considering it, we will get OC by AC, radius by radius by base, we can write here radius by hypotenuse, not base, radius by hypotenuse, we will get cosec alpha by 2. That means it is given from here OC equals to, AC is R, so R cosec alpha by 2. Fine. Now, next consider the right angle triangle ODC. ODC. So here in triangle ODC, from ODC we have, let's check, from ODC, from this triangle we can write CD by OC. Okay, CD by OC. So it's a perpendicular by hypotenuse again. So CD by OC means CD by OC will give us sine beta, because this time we are considering the angle beta, right? So here from this we can write CD as OC multiplied by sine beta, correct? Now the first result we can name it as equation number 1. So we have already got the value of OC from here. So CD equals to OC means R cosec alpha by beta multiplied by sine beta from 1. Okay, that means CD becomes R sine beta cosec alpha by beta, right? Here CD refers the height of the circular balloon from the ground, correct? So we can write that hence the height of the center of the balloon from the ground is R sine beta cosec alpha by beta. Let's check with which option it matches with. Is option B is the correct answer. R cosec alpha by beta. R cosec alpha by 2 sine beta. Yes, R cosec alpha by 2 sine beta. Question number 37 states that a man 6 feet tall cast a shadow 4 feet long at the same time when a flagpole cast a shadow 50 feet long. The height of the flagpole is, 4 options are given. Since they said at the same time, that means the position of the sun is same in both the cases. So we can write a shadow of 4 feet is casted by 6 feet tall man, right? Next, a shadow of 1 feet is casted by 6 by 4 feet tall man. Next, a shadow of 50 feet is casted by 6 by 4 multiplied by 50. In with the help of the plain unitary methods, we are solving this sum. So it's here 225 to 3, so 75 feet long, not tall man, but 75 feet tall flagpole. Tall flag pole. So here the height of the flagpole is 75 feet. Option B is the correct answer. Question number 38 states that the angles of elevation of the top of a tower, which is 30-meter high from 2 points on the level ground on its opposite sides, a 30-degree and 60-degree. The distance between the 2 points in the nearest meters is, there are 5 options given. Let me first explain the above scenario. Let's say here AB is the tower, which is 30-meter high, and on the ground on its opposite sides there are 2 points situated, C and D. From the point C, the angle of elevation is 60-degree, and from the point D the angle of elevation is 30-degree. Okay, so we are required to find the distance between this point, between C and D. Okay, so here we can assume that the length of BC as X meter and the length of BD as Y meter. So first, considering the triangle ABC, from ABC we can write AB by BC equals to tan 60-degree. That will give us the value. Let's put all the value. 30 by x equals to √3. So from here we can get the value of x as 10 √3. Let's name it equation number 1. Next, considering the second triangle ABD, we can write AB by BD equals to tan 30-degree. Let's put all those values. So here 30 by y equals to 1 by √3. After cross multiplication, we'll get the value of y as 30 √3. Let's name it equation number 2. So the distance between 2 points, the distance between 2 points are 2 points is x plus y meter. Let's put all those values. 30 √3 plus 10 √3 will give us 40 √3 meter. So here second option is the correct one. It is given in question number 39, a round balloon of unit radius. Unit radius means the radius is 1 unit. Okay, subtends an angle of 90-degree at the eye of an observer. Of an observer standing at a point, say A. So let's say here is the eye. This is the point A. Okay, what is the distance of the center of the balloon from the point A? That means let us assume O is the center of the balloon and we are required to find the length of OA. So here OC and OD, these two are the radius, both measures as 1 unit. Fine. And it has given that the subtend angle at subtend angles of 90-degree at the eye of an observer. So this is 90-degree. Since O is the angle bisector, we can say this much portion angle means angle OAD is 45-degree. Okay, and CAD, angle CAD is all total 90-degree. Correct. Now in here radius is perpendicular on the tangent. Look here, A is an external point. I mean the point A is an external point. So from A we can draw two different tangent to the circle with center O. So here AC and AD, these two are the tangents. That's why they are equal in length. Okay, and also we know that radius perpendiculars on the tangent, so we can say OD perpendicular to AD and also OC perpendicular to AC. That means triangle ADO is a right angle triangle. Okay, so from triangle ADO we can write, since OAD is 45 degree, so considering this angle, sine 45 degree will give us the value OD by OA. Correct? Here OD is given 1. Okay. And since this is 1 and 1 by OA, we already know the value of sine 45 degree, that is 1 by root 2. So from here we can say OA equals to root 2 units. So the distance of the center of the balloon from the point A is root 2 unit. Option B is the correct answer. Question number 40 states that the length of a string between a kite and a point on the ground is 80 meter. If the string makes an angle x with the level ground such that sin x equals to 11 by 10, how high is the level? Okay, so here we can say that at the point A, the kite is located and there is a point on the ground, let's say C. It is the position of the string on the ground. So the length between the string the length of a string between the kite and the point on the ground is 80 meter. Okay, and there is a point B on the ground just vertically below the kite. We are given that there is an angle string makes with the level ground x degrees such that sin x will give us 11 by 10. So let's consider the right angle triangle ABC. From it we can write AB by AC as sine x. Let's put all those values. AB by 80 equals to, already sine x, the value of sine x is given 11 by 10. So here we can write AB equals to t multiplied by 10, 88 meters. So the height of the kite above the ground is 88 meter. Option B is the correct answer.